Okay. Jonas Brothers ad. Jonas Brothers ad. All right. So we're going to make a flag called like that. Why is this not indenting? What? What is... All right. So, if binary arrow user flags, if it's marked as small, then get constant to literal binary right lit and lit type is asked literal. And you're missing Jonas Brothers ads. I thought, aren't the Jonas Brothers from like 8 years ago? Like, what? Why are there Jonas Brothers ads now? Do the Jonas Brothers program? What's going on? Is it like the Spice Girls where they're coming back and doing a movie? Like what? What's the deal? If it's a literal, oh, this reminds me of something that we have to do today. Once we finish this. Where is it? Oh my God, there's so many things on my list. There it is. That thing. See, I was doing great on this recent list, but then I page back and there's just things and there's things. They're everywhere. Okay, I did that though. So many things to do. Can you ask a programming question? Yes, you can. That is definitely an option that you have. Okay, so like, now, if it's marked as small, we set the small flag. Otherwise, if it's a literal, if its lit is greater than or equal to 0 and lit is less than bits, type binary left times arrow size times 8. Okay, if it's greater than or equal to 0 and less than bits, then oh, value, not lit. That's why my brain, I wasn't wanting to type that, and it's because it was wrong. Then, well, then we also set the known to be small flag. All right. Now, well, that's not really going to do anything. I don't see the point of using that for compile time execution, because checking the checking the flag at compile time is going to be about as slow as actually just doing the real check. But in our code generators, this will do a thing. All the JS, yeah, you mean in chat? Is that a yoga mat you see behind me? Yeah. I don't use it for yoga, though. I use it for a softer surface for other exercises. All the popular recommended books for languages are 2 to 5 years old. No, it doesn't matter. Like, you don't need the latest things about a programming language anyway. For arrays, should you go row major or column major? Who cares? It's probably application dependent. Okay. So we're setting this small flag. Let's just have that compile. Integer value is not... Okay, hold on. Lit. Oh. The reason I called it literal was so I could do this. Okay. Literal. There we go. Like, look, being a good programmer is not about following recent programming trends, okay? That's something that you should disabuse yourself of. It is, like, if you go on, like, Hacker News or somewhere like that, or, like, a lot of kids who just got out of college, they think that, like, what makes you a good programmer is if you know the new JavaScript framework or whatever. And that is not what it is. You don't need to care about that. In fact, if you're chasing that stuff all the time, it may well prevent you from gaining deep knowledge. So don't worry about it. You just want to learn how to program. You want to practice programming. You want to practice solving difficult problems and getting work done. It's been a while since we had a chai stream. You know, it has. I'm just really full. I just ate a lot during the break. If I'd thought of it, it would be a good chai stream time. You know what? Maybe we'll stream a lot tomorrow and do a chai stream tomorrow as well. Because I don't know. I just can't have any more food right now. I just ate a lot. Yeah, programming is not about knowing a specific programming language. That doesn't matter that much, right? Being good at programming is being able to understand what problem you have, being able to break that down into steps that you know how to solve, right? Being able to notice what's wrong with the solution that you proposed, and then being able to refine that solution and get all that stuff done, right? That's programming. And then you can do that in different languages. And some languages are better than others, right? But when you're just starting, you're not good in anything, so it doesn't matter. Just get practice. Okay, so this probably, it's not going to do anything bad. We're not looking at this flag at all right now. So it's like, well, there's a flag. Dude, our compile time is like magically going up. It was like 115 a couple days ago. It's 131. And none of the changes that we've done are affecting that. So I don't know what's going on. My CPU is getting tired. We're going to have to look at that eventually. Maybe I have something running on the machine. It's like something... Firefox spiked there, right, when I Control-Alt-Delete. Creative Cloud Desktop. That is a thing that I installed recently. How do I show all the CPUs? There we go. Like, how does that... All right. Like, these numbers don't add up to 13. At all. Let me close a couple of things. Close a YouTube. Close of that. Close of that. OBS, power usage very high. Well, I don't think that'll help a lot, but... Oh, there we go. We went from 1.3 to 1.19, guys. 1.20. That's more like what I would expect. Okay. Always be closing. Yes. Okay. Now, we want to use this flag, and as always, we're going to do it in x64 first. So remember I made this is small. Okay, well maybe this will just work, right? Because here we just didn't do this. We just didn't do this. Okay. So here I'm going to go, if we notice that something is small, interp report info binary inferred as small. So we just want to you know, hopefully in our A example, we just see a bunch of this. What did I get wrong? Binary. Oh, it's called op here. Just picking consistent names for your variables so that you can just do stuff is really important, actually. See, Visual Studio still thinks branch 8 is like not a thing. Like, this is why I hate this editor. It's just wrong. They add all this stuff and it doesn't work. Okay, wait, that's not the right one. It's x60. It's here. This one is op. Wait, no, it's not op. Oh, we don't have... Okay, duh. Right. This flag is on the expression, and we want to have boiled the expression down further into an instruction. This is like, I'm on drugs, dude. I didn't even... All right. So we're going to do this. Okay. So going to define this thing. We're going to go into bytecode.h. I don't really do this usually. All right, we'll just put it here. Bytecode shift flags. And we'll worry about the other one later. So let's just do BC shift is small. Okay, so we just need to set this flag if we see the expression flag. It's kind of stupid, honestly, to have to do, but whatever. Whatever, guys. Shift right. Oh God, we don't actually, this is like fully automatic. Get bin op from token. So when we emit binary, okay. All right, if operator type is equal to bitwise shift left or shift right, we do this if binary inferred flags, and this is just kind of goofy. I almost just want to copy over the inferred flags, but these might just be in separate spaces eventually. Like, you know, we only have enough space for 16 flags here right now, and to share that among all operators, I don't know. We'll see how it plays out. Okay, so anyway, then did we do the thing in x64? Yeah. Why did I put options here? It's BC shift is small. Okay. I could just, yeah, I don't know. Why don't I yeah, you know what? As I'm typing this, I'm like, meh. Is it called binary here? Yeah. Actually, yeah, we are. We're just going to copy this for all of them. Okay, so we're going to get rid of this extra one that I just put. See, sometimes if you don't like what you're doing, just change what you're doing. Like, part of your brain is like in the background, like saying, hey, this is not the best. So we're just going to do this. I don't know if this can see that. Maybe it can. Okay. So maybe it works, but I went back and forth. I vacillated so much that maybe I just broke everything. Let's see. All right. So it inferred all these as small, which is good. These are all in like windows. So most of these shifts, we are now skipping the wrap check, or all of these shifts we're skipping the wrap check. Note that we're never doing it. Some of these shifts had like 100 or whatever, right? And we're not doing it for those, which is great. Let me just double check. Or no, maybe the rotates had that. Let me see. Yeah, so, you know, we have 32, 33. Those aren't going off. 101, that's not going off. But like 7. Where's the... These aren't in order, which is the annoying part, because it's whatever order they got compiled in. So let's go to line 90. Left shift by 6. Left shift 3, left shift 3. Right shift 6, so that's all fine. Line 15. Oh, that was the MySwap2 thing that we did, that we debugged. So then we do some Windows stuff, but we probably do more stuff from this file. No, we don't. Okay, I'm actually a little concerned. Okay, so actually no, because we wouldn't see these for constant shifts, because those are constant expression evaluated. So none of these would hit the code path we just did. It's only these. And rotates, of course, wouldn't either. So we're good. I'm going to delete this old stuff. Yeah, that looks correct to me. And then we're finding a bunch of stuff in Windows that probably should be cleaned up, because that doesn't really look like good code. I don't know what that is, but let's take a look at what that is. This is GUID stuff. This looks terrible. Like, okay, wait. This looks like just put the bytes in the right place. Like, what does hex do? Okay, it's just putting letters into numbers. Like, instead of calling this function a bazillion times, I don't know. I don't know, man. Because it looks like each digit is 4 bits of the GUID. I'm sure this is a direct transliteration of some Windows function, but this is terrible, dude. Because you're either calling a zillion functions or you're inlining the same thing a zillion times. Blah. Blah. The whole idea of GUIDs is terrible. I have never used them for anything except to have to deal with Microsoft APIs. Make a function that loops over the digits. Yeah, it's just the only problem is, so I thought, well, maybe copy the string. So first of all, you could just copy the string and do it. You don't want to overwrite whatever string was passed, but you could copy the string and do it. And frankly, with the way we do temporary storage in this language, that would probably be faster. Like a string copy. In fact, you would copy and do the hex at the same time, right? I'm not going to do this right now because, God, this is off topic. But so you could do that. Or after you put them into the target memory, you just do 2 digits at a time, right? You read a byte, you get the upper 4, you do hex on it. You get the lower 4, you do hex on it. You write it back. Either way. But this whole thing is like, this is just making an integer in a specific byte order. But like, just put this into an array of characters. Yeah, I don't know. I don't know, man. Program should not assert on user input. I agree. Well, it's unclear that this is user input. Like the way that this is used in this particular code is there's just GUIDs defined as strings somewhere. But yeah, this is kind of awful. We're going to have to change this. Part of why this is also here is that, like, we don't have good struct literals still. Maybe that's the next big feature, is actual struct literals. Anyway. Okay, so this is working in x64. Okay, let me, actually, that's in type checking. So I want to go all the way here. Because maybe for some reason we're not getting all the way there. I mean, I think we are because it's a very straightforward flags copy. Oh, haha. I deleted that. I was like, what's going on? How could we break it? Oh. Okay, well, it's... Oh, we didn't do the x64 backend. There we go. Okay, so now we're reporting these also, these that are explicitly small. Erroneous use of small. Okay. So that is getting all the way to x64, and we have our is small, and we use it in all cases, so I think that's a win. Boom. So now we go frickin' LLVM. LL Cool J VM. Okay. And we're going to do the same thing here. So shift left and shift right are going to want to know small. Why did I delete the old version? All right. Okay. So here we're going to go if is small, else we do this stuff. And we're just going to go if it's signed. Okay, this is going to get more complicated, but that's fine. And this is by cast B, else L logical shift, right? Okay, great. And then if it's small, so we're going to report this, by the way, up here as well. If it's small, else okay. Whoops. Okay. So now we should see this on the LLVM backend. There we go. Same things. Great. Ship it. Oh, well, let's compile our game with both backends and make sure that we didn't destroy everything. And the tests. Okay, that's with x64. This is with LLVM. Okay. Let's take out, this is going to be obnoxious. It's like, okay, it appears to work. Great. Is Jacob Lee in chat? I don't think so, but we're not doing anything hard. Oh, there you are. We're not doing anything new. The next thing we're going to do is let you control whether a shift's arithmetic or not, but that's not going to change. That's just changing the if statement. It's like not, we're not doing any more serious LLVM stuff tonight, I hope. Okay. So we're going to do tests in LLVM. And then we're going to do tests in x64. Whew, and then we're good. Can it run Crisis? Okay, so we're going to check that in. I remember accidentally clicking on this. Okay. Added comma small option to bit shifts. Okay. So next, we're going to have this logical flag that we added, but we're going to do it a little different because what's going to happen is you're going to mark it as logical, but then during type inference, we're going to decide if it's an arithmetic shift or not, and we'll set arithmetic on this. And that way we don't even need to check the number signedness, right? So we're going to say why is this not? What is going on with Emacs? It's just like totally broken now. It doesn't understand this for some reason. Guys, get your act together. Okay. Now the thing, I've already used my spider senses tingling because we can set this in type inference. But the place that we're deciding to set these things is after we try to constant expression evaluate it. So our const expert evaluation needs to check this instead, which is goofy and not good. I'm getting tired. Programming's taken a lot out of me today, guys. I might pass out soon. Anyway, so we're going to go to back here and we're going to set this flag when we're doing stuff here about oh, actually, okay, so we can actually do this first. Okay. Okay, so we're going to check under what conditions do we check the arithmetic. we say if it's not flagged as logical, right? If it's flagged as logical, that means it cannot be an arithmetic shift. Otherwise, it is an arithmetic shift. Okay? Okay. Now, if it is marked as logical, but it's a left shift, there's no such thing as a logical shift left. That's for goofballs. So we're doing that error checking here. Okay, so now we set arithmetic if and only if it's signed and you don't say logical. Okay, so now what? I'm sure adding lines of code here. So here, we don't do number flag signed anymore. We do if BC options and shift is arithmetic. That's it. Is that the right name? Let's see. Why does it take so long? All right, so that's good. We're going to do that in LLVM as well. Great. Good thing we didn't test that at all. Let's see what happens. Did we break the game? Not with x64. Did we break the game with LLVM? Also, I should try running the editor. One time, like a week or two ago, people were having problems running the editor. Like the editor was crashing on basic stuff, and it was because I messed up type information. It was bad news. All right. No, this is great. Okay. We'll run the tests. And then we will, while the tests are running, we'll go here and we have modifiers. Oh, we have logical. Right. So let's assert on the values here. Oh. Right. We want to do these constant and then non-constant. Right? Because they have to work in both. And they don't currently because we didn't. Okay, we didn't do logical in half the places we need to do it. I hate to say. Okay, we did do it in 2 places we do need to do it. Okay, Where else do we need to do it? We need to go to bytecode runner and run shift bin up. All right? We're going to swap this around. We're going to do this, and here, and here, and we're going to say if BC options and shift is logical. Boom. So easy. Let's test that. Might not be that easy. What did I do? It's not called shift. What's it called? Shift. Oh, shift is arithmetic, right? Sorry. Arithmetic. Okay. So really, only right shift when it's arithmetic goes through this code path, right? Left shifts, we don't care, signed or unsigned, it all goes here. Should be fine. Now, we also need to go to constant expression evaluation. And we're going to swap this around. And we're going to say if there. Who knows? We may have just broken everything in the universe. Maybe the compiler will never run again. Maybe it's fine. Maybe it's fine, people. Okay. Okay, so F1, 2, 3, 4, F1, 2, 3, F, let's pick a better number. Whoops. Okay. So basically, C is a right shift logical by 4. Right? Whereas B is not logic. Okay. This is signed, bro. If it's unsigned, logical shift ain't gonna matter. Okay, there we go. So B is arithmetic shift, C is logical shift. B is arithmetic shift, C is logical shift. If I had that in C++, all these times when we're doing this twice, I would just have half of that. And it's more than it looks like because this is a massive macro substitution, right? It's a double macro substitution. So like we would be half the number of cases because you would just say like logical or not. You wouldn't have to you wouldn't have to have twice as many types. Okay. So let's check this here. It's also working there. That's our bytecode execution that we just did, and it's working in both backends. That is everywhere that we need to do it. Oh, I didn't change the numbers here. Okay, let's put in some asserts. Right? Assert B is equal to this. C is equal to a 0 there, and we're just not printing the 0, right? But it's like, okay, we shifted and we shifted, right? And then D is equal to oh, that's the wrong D. I was like, why is that in decimal? Wait, these are the wrong numbers. Why do I keep... Why am I a bad person? Okay. And then we're going to get D. Is going to be F4, 5, 6. No. 3, 4, 5, 6. Oh, right? 32-bit numbers seem so small now. They're like quaint. Especially after staring at damn Visual Studio pointers all the time. All right, so did I mess that up? Yep. Line 171. Let's just print for, let's just comment that out. D 45670000. Okay, I was off by 1. Somehow. All right. Great. This is so good. Now we commit, and what have we been doing? Okay, first I check for a no check-in. There might be one. Nope. Okay, what did I just do? I've just been programming. We were, adding modifiers, comma logical and comma small to bitwise shifts. Like sometimes I just have no high-level concept of what is happening until we're done. Okay, let me go to the change log. To perform a logical shift right, non-sign extended even on signed types. Okay, that's great. That's great. Look at all these things we're going to deliver to our beta testers. They're going to be happy beta testers. I mean, it's not as much as last time, so we got to keep adding things, but you know. We need to do like a day of small fixes to just crank out more lines here. Imagine having to write everything in 16-bit numbers. Ugh, that would have sucked. What's comma small? Comma small means that you are telling the compiler that you are not shifting by more than the size of the word, and so it shouldn't put in the safety. Okay. Now we can promote this to a test, right? Because we have rotate, but What would we call this one? Constant shifts and non-constant shifts. Let's call it const expr shifts and rotates and modifiers. Okay, I'm just going to do this. Bam. Now, of course, this thing doesn't like main right now. Okay, great. Really? Oh, because I just ran the debug compiler accidentally. And we ain't built that in a long time. There we go. That's what we just did. Do we do overflow checking for other operations? No, not yet. We will. We will eventually. So just like with array bounds checking, we do it by default in a debug build. And then if you're making a release build, you probably turn that off because you want it to go fast. Same thing with math operations, probably, except that one's a little more debatable if it would be on by default because it might just be very slow, right? But we will have that. We just don't have it yet. Does overflow panic or wrap like Java? Well, you would be able to make it wrap if you want. Kind of like we had these modifiers. There would be a modifier that says, I intend for this to wrap, bro. And if you don't do that, then it probably panics. But, you know, I don't know. It is UB to overflow a signed integer in C++, by the way. It's not UB to overflow an unsigned integer. So that might be, I have other stuff on my list that can be done, but I'm kind of tired, and so I don't want to do anything serious when I'm tired because I'll just break it. So this might be the end of serious programming, and we can just do questions and answers. I don't know. Movement system rewrite 7 times. No. Movement system is doing well. Movement system is handling the situation. All done with shifts. You promised that then it's time for structural. Well, I wouldn't try to do good struct literals tonight because I would make a mess out of it. There is more stuff we could do with shifts. However, I think this is good for now. I think this is the right amount to do right now. There might still be bugs in what we just did. There might be interactions or corner cases that we didn't think about. I know what I need to do. There's a one thing that we need to do, and it's easy. It is a kind of a bug that is going on. Okay. Ha ha. Okay, so when we do compile time execution, then the return value, right, when we get the return value back, we take it from one of our pseudo machine registers that we run interpreted, and we make a literal that we can put back into the syntax tree. We do not set the negative flag on this. Okay, and we need to do that for, remember over the past week, we've done a few times where we were like, we'll just check the negative flag on the numeric literal because that's set at parse time. Yes, but that's not the only place you get a literal from. And it can't be from number flags either. Let me see what that says. That might be wrong. Yeah, no, it doesn't do that. So we want to say literal numeric minus sign if right, if value is less than 0, we set literal numeric minus sign. That's been bugging me for like 5 days. And we just did it when I said I was tired, and things work. Could it be a bug for shift if you intend it to be a power of 2 multiply? If you use a shift instead of a multiply, know what you're doing. Also, yeah, like, yeah, I don't know. Like, assuming that your compiler isn't just going to do that, that's one of those optimizations that compilers are very good at, is turning a times 16 into a bit shift. Compilers will do that 100% of the time. Well, close to 100% of the time. Don't worry about that. Just say times, 60% of the time it works every time. So don't worry about it. ETA for the modules demo. I'm not going to do any more demos. Not going to do any more demos until public beta. Plus infinity. No demos. Yeah, I mean, like I said, I'm just tired of the way that people use my information sharing when it comes to programming languages to like turn around and release their own lower effort version of what I'm doing. I don't like that. So I'm going to stop giving people that information. And I'm sorry that that means that civilians don't get that information early, but it's like, you know, what am I going to do, right? So it is what it is. Maybe I'll change my mind about that later. That's possible. It's just I'm not in the mood right now. I won't say I definitely won't ever do more demos until public beta. I'm just not in the mood right now. I don't feel like it. So, you know. Has this info stealing been a serious issue? I wouldn't call it stealing because I was giving out the information, right? It's not stealing if I tell everybody. Has it been a serious issue? Hard to say. I don't really think so, but I just don't feel good about it. Like that's the thing. Like if I do a bunch of stuff and then as a result of what I did, I just feel crappy, then maybe I shouldn't do that. Right? So that's the thing. I mean, like I work really hard. Unlike a lot of people, my life is mostly oriented toward game programming and now compiler programming, right? Like I don't do a lot of other stuff. I go out a little bit and do fun things, but I work way more hours than most people. And the reason I do that is because I have a lot of things to do and I'm trying to get it all done and I work really hard on it, right? And then to have people who aren't working that hard just turn around and like, oh, look at my thing. It's better than his thing. It's just like, fuck you, dude. You just, the whole reason I'm working this hard on this is to try and stop the tradition of people pooping out software as soon as they have something that runs. And then you as a user have to, you know, go through all the suffering of dealing with an immature thing that, by the way, never becomes mature, right? And so I'm trying to like set a model of like serious engineering going into these things. And people are just using the ideas to dump on that model. It doesn't, that's why I feel so bad about it, right? So I don't want that. Yeah, I definitely feel good about my work for sure. I just, you know, I'm not talking about any particular other project in specific. It's more like an aggregate of behavior from like 5 or 6 different people. I don't mean to diss any particular person. It's just I don't feel good about the way that these things were used. That's all. Curious if I have opinions on software licenses, GPL versus MIT. I don't like GPL. I just don't, for a lot of reasons. I would MIT over GPL. I have notes here that I can't read. Improve syntax highlighting on enum error message. I don't remember which enum error message that was. like some of these are from less than a week ago because I've been cranking and I just don't even remember because I've done so many things. Sounds like I can't trust the audience to be respectful of the work, and that's unfortunate. It's not that I can't trust exactly. It's just that, and it's not the whole audience. It's like a small number of people. Most people are fine. Most people are great, you know. It's like chat. Like most people in chat are totally good and just chilling and hanging out. And then a couple of people show up and they're toxic and it just changes the mood of the whole thing, even though most people are totally fine. So write down stream timestamps on my notes. Well, that would help if I was streaming all the time, but I'm definitely not streaming more than probably 2/3 of the time that I've been doing these things. So I don't think that would help. I can just take better notes. There's lots of things that could be done here. But I think it's going to be bedtime, and then tomorrow, I don't know if I'm going to stream it, but tomorrow I'm going to very happily get rid of the dependency system. We'll see. Maybe I'll stream that because the secret sauce. Well, I don't want to stream the secret sauce. Type unsigned removal. What does that even mean? Oh, that parameter. Yeah, we deleted that. It was a parameter from one of the macros. Subscript cleanup. I don't remember what that means. Subscript cleanup? Do I have interesting ideas about modules that I could demo? Yes, I do. But honestly, they're not the most interesting. Like modules, there's some ideas, but they're not so far huge ideas that define the language, whereas other things are. Strobe light. Why do I stream? I feel like it sometimes. Sometimes it feels really good and positive and motivating to like stream what I'm programming. That's how a lot of today was. And people like to see what I'm doing. People really appreciate the information sometimes, so that's good. Do I disallow import cycles? No. No. Absolutely not. That's BS. You're making assumptions there. We already only compile every module once. We don't need to disallow import cycles to do that. Oxygen. Well, if you look in the beta, right, this how-to folder is my first cut at documentation. It's obviously woefully incomplete right now, but the idea is you just go through the sequence and you learn about stuff, and eventually, hopefully, this has all the features in the programming language, or all the major ones. Right now, it's very far from true, but this is sort of the initial documentation that I'm working on, and then we'll see. Can I, as a developer, see if you bought a game to play on Linux or Windows? I would say that depends very heavily on the platform. So on Steam, we just get total numbers. We can't tell by individual people, but we can tell, oh, this many people bought on Linux and this many people bought on Windows. Do we have references or just plain pointers? It's mostly pointers. There's a little bit of reference-like stuff, but it's not an actual type in the type system. It's just in some cases, like struct, or in some cases like function parameters, if you pass something by value, it's like really a reference, but you can't make a reference. Do I feel a large-scale program in a language without memory safety guarantees can be extremely stable? So of the bugs that we deal with, both in this compiler and in games, okay, the percentage of bugs that we have that are memory safety related is 0%, rounded to the nearest integer. Okay, it's less than 1 in 200 bugs. So it's just not a problem. Like the time when memory safety like that is a problem is in a security critical thing where the cost of a bug, like there's a security cost that is very, very high. Then it makes sense to me to be that paranoid about memory safety. But again, it's 0% of bugs. So I don't see the issue. There are many static and dynamic analysis tools if memory safety bugs need to be found. That is true. And that's one thing that I do. So like, if I'm working on a game, like once a year, I'll bust out, Dr. Memory or something and say like, do we have, are we stomping over the end of a buffer or something? And usually I'll find something, right? But I won't find a lot, and I'll find false positives. And, and that tool did the job, right? Is that as good as static assurance? No. But in a language like Rust, you pay for having static assurance in what you're able to express. Like you can't do a doubly linked list. So any possibility of a switch port for the witness? I don't know. I wouldn't say never, but we're not working on it. You like the no BS style. Well, thanks. Is there consistently one type of bug that appears the most? Not really. Like the biggest problem is just that the situation is complicated. Like that's really the source of most of the bugs. Games are complicated, compilers are complicated, things are just complicated, right? And most of our bugs are like, oh, we didn't think of that, or oops, we were trying to do this thing and we just did it wrong. Right? It's not memory safety. Are the language types fixed size across platforms? Yes. Yes, they do not randomly change. How livid would I be if I were working on a AAA game and key plot elements were leaked months before its release? I probably wouldn't be that upset because I don't think that plot is the good part of games. I think you can do doubly linked lists in Rust, but you have to use gross semantics like weak references. Yeah, I don't know. I've just heard that that's a thing. I haven't programmed enough in Rust for that to be a thing for me personally, so I don't know. In my opinion, how similar is programming language design to game design? I don't know how to answer that. They're different, but I definitely use the same part of my brain somewhat. I use the same aesthetic sense to some degree on both. Alrighty, everybody. This was a short third stream, but it's been good. We did things. We got things done, and probably I'll stream tomorrow. We'll see how that goes. Thanks, everybody. See you later. See you later.